Alright, hello Titans. My name is Mr. Spilker and I am kicking off your 2014-2015 school year with the teaching video for Chapter 1, Section 1. So on your notes, go ahead and write 1.1, Chapter 1, Section 1. And the title here is Using Differences to Identify Patterns. So I always just write in my notes 1.1, Identify Patterns. So go ahead and get that heading on your notes. You want to take notes during this short lesson. Your notes do count as a grade. So go ahead and I'll try to highlight what things we want you to write down as we go through this lesson, and then you can show your notes to your teacher tomorrow, and they will give you credit for the notes from Chapter 1, Section 1. Alright, we're going to start off the lesson here today with a couple teasers. So what I want you to do is I want you to look at these two questions and then pause the video and give them a little bit of thought. See if you can make an educated guess as to what the answer would be. The first teaser question is, what is the pattern that exists? So I'm giving you the numbers 2, 5, 9, 14, 20. What is the pattern that exists in that number sequence? The second question is, suppose that 10 skateboarders are attending a competition. Each skateboarder is going to shake hands with each of the other skateboarders to wish them luck. Using your problem-solving skills, determine how many handshakes would occur between these 10 skateboarders. So give those questions a little bit of thought. Maybe pause the video if you want and make a guess, and then we'll answer these two questions at the end of our lesson today. Alright, the objectives of our lesson here in Chapter 1, Section 1 are to be able to use differences to identify patterns in number sequences, and the second objective is to make predictions by using patterns in number sequences. So this is Chapter 1, Section 1. If you want to follow along in your textbook, we're on page number 4. Alright, we have three definitions here for Chapter 1, Section 1. The first definition is a conjecture. A conjecture is a statement about observations that is believed to be true. For instance, most of you guys, when you came into my classroom, you probably looked at me and said, man, that guy must lift a lot of weights because you saw my rather large biceps. Once again, that statement from you was a conjecture because it's a statement you made that you believe to be true, even though you haven't seen me actually lift weights. So a conjecture is a statement about observations that is believed to be true. Our second definition is a number sequence. A number sequence is a string of numbers or terms that are placed in a certain order. Our third definition is a constant difference. When the difference from one term to the next in a number sequence is always the same, we call that the constant difference. Once again, Titans, you are allowed to pause this video. You don't have to necessarily hit play and then just be writing with smoke coming from your pencil because you got so much to write down. Feel free to pause this video, feel free to rewind it, go at your own pace. Alright, now that we've covered the three definitions, let's go ahead and get into some examples of questions that will be presented to you in this section. Now before I get in those sections, I just want to quickly mention why we are starting off this book, this course, by studying patterns. Well guys, patterns are important. Patterns are all around us. One area in the real world that you see patterns is in nature. What weathermen do is they analyze these patterns. And when they analyze these patterns that occur in nature, it helps them understand nature better. So weathermen will study past weather patterns, and then they'll use those past weather patterns to predict future weather. Now that's the same way in mathematics. In mathematics, we study patterns. These patterns help provide us with tools that can help us understand different equations and different expressions that we'll be studying here in algebra. So patterns are useful because by studying patterns, it can help us predict future outcomes. Alright, example number 1. You can go ahead and put this one in your notes as example number 1 from section 1.1. In example number 1, they give us the sequence of 9, 11, 15, 21, 29, and they're asking us to go ahead and figure out what the next two numbers would be. Now, some of you may be able to just look at this sequence and you may be able to say, oh, there's the pattern. Here's the next two numbers. But for some of you, it may not come that easy. So what we're going to do is we're going to give you a mathematical way of searching for the pattern. And that mathematical way is by looking at what we call the differences. So what you do is you take the first two numbers and you look at the difference. So let's look at the first two numbers there. We got 9 and 11. What's the difference between 9 and 11? That's right, it goes up by 2. Then we look at the difference of 11 and 15. What's the difference between 11 and 15? Yep, that's right, 4. Then what's the difference between 15 and 21? You're right again, 6. Then 21 to 29 would be an increase of 8. Now, if this pattern continues, what would be the next number? And then what would be the number after that? Well, some of you may look at this and say, okay, well, I see it's going up by 2, 4, 6, 8, but I don't know what it's going to go up by next. Well, then you would look at what we call the second differences. This is the same question. As you notice, we switched slides, but it's the same question still here. What you would then do is go ahead and look at the difference between the first differences. So what's the difference between 2 and 4? 2. 4 and 6? 2. 6 and 8? 2. Okay, now you may see that these first differences keep going up by 2. So you would guess that the next difference would go from 8 to 10. And then from 10 to 12. So if we keep these differences going, 29 plus 10 is 39, and 39 plus 12 would take you to 51. So the two missing numbers are 39 and 51. We found those two numbers by working backwards using what we call the differences. That's the mathematical way to do these problems. All right, let's look at a couple more examples here. It says find the next three terms of each sequence by using constant differences. So what we're going to do here is we're going to go ahead and find what the next three terms of this number sequence would be, and we're going to do so by looking at differences. So let's jump right into it. 80 and 73, what's happening there? Oh, I can see it's going down by 7. 73 to 66, oh, going down by 7. 66 to 59, oh, down by 7. 59 to 52, down by 7. So as you can see, it keeps going down by 7. So if it continues this pattern, then we would take away 7 and we would get 45. We would then take away 7 and we would get 38. We would then take away 7 and we would get 31. Now, as you heard in our class presentation today, myself, Mr. Simpson, Mr. Wills, we've taught algebra for a long time. So, in dealing with students in this section, most of the time when they're like, oh, I don't see a pattern, there's no pattern, what's going on here? It's because they made a mistake with their addition or subtraction. So if you do this and you don't see a pattern, maybe go back and make sure that you have the first differences correct. Another example, example B here, 1, 4, 9, 16, 25. From 1 to 4, what does it do? It goes up by 3. 4 to 9 goes up by 5. 9 to 16 goes up by 7. 16 to 25 goes up by 9. Oof. I don't see a pattern. Well, if you don't see a pattern with your first differences, go ahead and find your second differences. So as you can see there, oh, these keep going up by 2. So the next difference would be 11, which would take me to 36. The next one would be 13, which would then take me to 49. And then the next difference would be an increase of 15, and that increase of 15 would take me to 64. So 36, 49, and 64. All right, now that we've showed you a mathematical way to find patterns, let's go ahead and jump into an application problem. Suppose that 8 friends have just returned to school. Each friend has exactly one conversation with each of the other friends to talk about what they did during summer break. Use the problem-solving strategies to determine how many conversations there will be. Well, ladies and gentlemen, we are presenting you with an application problem. This application problem is in the pattern section. So can anybody guess what this application problem is going to have in it? You guessed right, a pattern. Let's think about this. Let's break it down. Let's say there is one person. All right? If there is one person, how many conversations is there going to be? Well, you guessed it, 0. Talking to yourself doesn't count. Imaginary friends do not count. So, one person, 0 conversations. If there's 2 people, think about this. We got, I'm a good artist here. I'll draw a couple stick figures. We got person 1 And we got person 2. If they talk to each other, how many conversations would there be? 1. Okay, let's add in a third person. I'll have this third person be myself. As you notice, I'm a little bit taller than most people. And yes, I drew my biceps in there. Now if there's 3 people, these 2 people are going to talk, these 2 people are going to talk, those 2 talk. So 1, 2, 3 conversations. So 3 people, 3 conversations. Now if we add in a fourth person, now notice there was 3 conversations. So here's conversation 4, 5, 6. So if there's 4 people, 6 conversations. Now some of you are already realizing, man, this is getting messy. Look at this. He's got lines drawn everywhere. I don't even know what's going on. Well, look at the pattern, folks. It's going up by 1. It's going up by 2. It's going up by 3. What do you think it's going to go up by next? You guessed it. It's going to go up by 4. Then it's going to go up by 5. Then it's going to go up by 6. Then it's going to go up by 7. Then it's going to go up by, oh, it doesn't need to go up anymore because there was 8 people. So how many conversations would there be? You guessed it, 28. Once again, how did I find that out? Well, I used some basic logical thinking, and then I just extended that pattern. If there's 8 people and they all talk to each other, that'd be 28 conversations. All right, here's the answers to the 2 teaser questions, 27, 35, and 44 for number 1. In question number 2, there's 45 handshakes. All right, students, that wraps up the teaching video for Chapter 1, Section 1. Make sure you have notes. Make sure you're ready to go tomorrow. If you would do me a favor and quickly sign the Google form that is below this video, we'd appreciate that. That way we have documentation that you did it, and that way we can get some feedback as teachers as to whether you understood the teaching. Once again, this is not just the end of the lesson. We'll expand on this tomorrow in class with some practice where you have a chance to get help from the experts, the teachers. Thank you.
Made with Doodlecast Pro.